good afternoon, everyone. Our team name is Safe Walk. So we came up with an idea. So many people will be walking every day. So we want to make sure our main problem statement is to ensure a safe travel to the user. So we know that if we want to walk somewhere in the campus, we'll all feel safe because of we know the place and all stuff. So what if we move to a new place? What if we walk? What if some situation happens where we need to walk? So we want to ensure a safest travel to the user. So what we've decided is to take 2 points, the starting point from where we are starting and the destination. So we use NYPD data, crime data, to categorize into different types. There are almost about 150,000 and above data sets. So from that, we took just like 5 or 6. So from that, we've categorized the events into many types, like something related to robbery, something related to car mugging, something related to theft, something related to violence against women. So we've categorized those, and we try to give the user based on his needs. For example, if you take a street and there is a problem for women's safety, so that means men can go. They can walk. We're just letting the user know everything, what's going on, so that he can choose the safest path. So that's what we chose. And after that, as I told you, we took the website NYPD complaints. We took the data from there. And so we pointed the locations, like which is the safest one, which is the safest path and which is not safe. And we've pointed the points in the map based on the latitudes and longitudes. So this is our demo. So if we enter the starting location, for example, if we take Manhattan and exact latitude point, and if we enter the endpoint location, it gives us like 2 or 3 paths. One which has this type of crimes, and one has this type of crimes, and one is the safest and one is the shortest. So depending on that, user can choose it. So we are trying to add more things into it. We are trying to add we are trying to make it user friendly, so that when he is walking, he can also point some things in it. Now Yash will explain.
So next we are thinking to create a mobile responsive UI. So for now, we just created a web-washed application. So demo. Okay. I will show the demo of it.
You okay?
Yeah. Woo! Give him a big hand! Our first group!
He wants to give a demo.
Oh, we're going to the demo. I thought we were done. Well, how much time do they have?
Oh, it's okay, we're done.
I did not hear that. Okay, keep going.
You go, you give me a
I
demo.
interrupted you. Keep
Go
going.
ahead, keep going, plug it in.
How did I
The
miss
other
that?
side.
But good clapping,
The other
good
side.
practice. He said we're going to the demo. I thought he said and eventually we'll demonstrate.
Yeah.
Words matter, people. I can demonstrate. I'm walking through campus.
How do I make it big?
How's the crime rate?
What?
How's the crime rate?
Oh my God, I'm being
How do I
accosted.
make it big? How do I make it big? I don't know Mac.
Sorry, I really didn't hear that. God, that's embarrassing.
So this is a web-based application that we built, but currently it's not the website that we have expected. We could do only this much of part in the given time. We can enter the start location here. For example, we are giving Times Square, and here for the end location we are giving Manhattan. And after clicking the Find Safe Routes, it will provide a safe route that is highlighted in orange color like this, and this is a score. The higher the score is, the more safer the route gonna be. That's what we build currently for now. That's it. Thank you.
Woo! All right. Sorry about that. Beautiful. That's my old house right there on West 84th Street. Thank you for showing it. It was not safe. That is the way it's done. Next group, come on up. Okay, let's go. Safe connect. Thank you. You can leave that right there. Safe commute and green walk. No. Oh yes, you're right. Judges. I made another error. That's 2 in 1 hour. Go back. Safe walk. Come up. We have 5 minutes for questions. Thank you, judges. Boy, I'm out of practice. First one. Sorry about that. They get a little extra time because safe walk. Questions. Yes. You go. Oh, you're deferring to Josh.
First question, what are you doing to mitigate against discrimination lawsuits?
Repeat the question.
Sorry, I have. Yeah, I'm a little loud on these things. So, what, if anything, are you planning on doing to mitigate against discrimination lawsuits? Say, for instance, your your company gets fully operationalized, gets funded, and then a neighborhood basically bands together and sues you and says, you're discriminating against our neighborhood for, by saying that it's unsafe.
Yeah, it's a good question, but for some users who are living in very much unsafe places, we feel it's a necessity to know, and for travelers who are coming from another countries, they wanna visit place and they don't want to get lost in something that's not in their hands. So at least it will be helpful for them. So what do you think?
This is based on the NYPD complaints data. So we can say that it's from the public source data by the police itself, and some of them are actually committed, and some of the crimes may not be committed. So yeah, we are just giving the users a heads up that there might be a chance.
So if the neighborhood, if a crime doesn't happen in a neighborhood for past 1 week, then automatically the score is too low. Then it obviously becomes the safest place. So that's the point.
Yep.
Next judge, question?
Yeah, thank you.
Only the judges get to ask questions.
Okay, thank you. That was an innovative idea that you came up with. Can I ask what kind of AI did you use, and or if you did not use it, if you think we'd be using it, what do you plan to use in it? I have another question after this.
Did you hear?
What we're gonna plan?
Can you be more specific, what AI?
So, do you plan to use anything from AI into your project that you are proposing, or no?
For the time being, we'll just use the past, historical data, but moving forward, this can be used to kind of predict sort of which neighborhoods can be safe based on certain factors. But as of now, it's not in the plan.
Thank you. Second question, or my last question is, what is the subscriber base, or what kind of model do you want to bring it out to the market? Do you want it to be a monthly based or yearly, or how do you envision that? Following up with what Josh was talking about, when you bring it out to the market, how do you envision this would help the user to pick this based on what you're proposing to?
So it helps many international students and many people who are walking. So we are trying to make it as a affordable pricing.
Monthly basis.
Yeah, based on monthly basis.
And also we are thinking to create an
No more
environment
questions. No more
whoever
questions.
joins the
Yulia. No more questions.
whoever joins the application, they need to at least give a safe point or a negative point wherever they visit. Suppose if they visit Manhattan in a certain place, and based on their experience, they need to at least give a view, whether it's a neutral view or negative view or a positive view. So it makes the community engaging. Everyone can have their own views and also like that.
Okay.
Last question. Do you have a question?
Last
about-
question, yes. So, did you do any existing art study to see if there is anything, something like this already exist?
No, currently we did not reference it from anything. It's just an idea we thought from the given open data. No, yeah, that's it.
Okay,
We
thank
didn't
you.
got reference from
All right, listen, we're regrouping. We have 7 groups, that's 5 minutes each, that's 35 minutes, plus the on and off, plus some time for the judges. We must be succinct, that doesn't include deliberations and thank yous. So we gotta rock and roll, let me hear you say it. Rock and roll.
Second
With
group,
that,
come
Safe
over.
Commute is up and on deck, get down there, green water, green walk. So there's, come on, green walk, come on down on deck. Safe Commute, you're up. Green walk, and after them will be Smart Predict. All right, you guys are good? You have the mic? Can I have the- Yeah, we're gonna give the judges 3 minutes. Here, guys. Oh, my daughter has a dachshund. She would live there.
You introduce it?
All right,
just going
ready?
down one.
Look at William, you see your timer?
Our group is. Yep.
Yeah, so I'll introduce it. I introduce it as seminars. I choose a group seminar.
Say what you're doing here. RPS. He's like here.
Let me know. This mic?
No.
Oh, well, okay.
Begin.
All right, we are New York City Safe Commute. I'm Adam. I'm a junior here at RPI, double majoring in ITWS and Business Analytics.
Arman, I'm a senior computer science student here.
I'm Dan. I am a master's student in IT.
And I'm Colin. I'm a senior computer science student here.
All right, so the problem statement similar to the last group is commuters, specifically in New York City, especially ones who are not familiar to the area, would like safer ways to choose transit routes, walking routes, driving routes, whatever, due to crime and safety concerns. The way we thought of this was, we're all from the area, but like going to other cities that might have different crime records, it's definitely something useful for your own vacation. So our evidence for this is that over the last couple of years, there's on average about 120,000 cases of the suffering major felonies in New York City. So there's a lot of commuters who feel unsafe. It's a hot topic of discussion in the local area. The map we have on the slide deck is the crime relative to the rest of the country. So that's why a lot of it is in red and orange rather than green.
Okay, so I'm going to talk about a little bit about our solution. So our application has 3 main points, or 3 main features. So the first feature is our map, which is going to show a gradient of crime across New York City, Manhattan specifically, is what we scope to. Then the user can input their starting point and their destination, and then we generate routes and display recent crime incidents near these routes. And there will be clickable markers that display more details for each crime. And we're using New York City's open data. So you can see our flow chart here. So first, we display the map, then the user inputs their starting point, then we retrieve the routes as well as the crime data, then we display all of that on the map. The next point on the flow chart I have in stars because this is something we potentially would implement in the future, is AI evaluation of the data and offering a recommendation of which route to take. And then the user can evaluate all of the information that we've given to them and make their decision. And then we're going to show you our quick prototype.
Yeah, I'll just give a quick demo. So this is our website. Right now, because of the APIs we're using, we have to enter in like latitude, longitudinal coordinates. We can see right off the bat, we load in like a bunch of like crime zones. So like here, there's a lot of felonies. Here, there's a lot of misdemeanors. And then you can enter your 2 points. So like if we enter in these two, you can see it'll provide 2 different routes here with directions to both of them. Right now it is driving data, but we can also extend with something like Google Maps to do public transit and things like that. And you can see that this route here passes like a felony zone, and so you might want to avoid this route and instead take the other route. And obviously there's a lot more that we would add later. As for value and impact, we combine public crime data sets with our real-time public transportation routing. We're accessing real data so we can see the most efficient routes. And kind of our future plans, our impacts that we increase commuter safety and peace of mind for people that are new to the city or just want safer routes. And as for future plans, we want to expand outside of Manhattan, use more crime APIs, and then potentially use like an AI search for current events, and then have like, sort of like if you guys know about the Citizen app where it's like live feeds of like different crimes going on in areas, we can kind of pipeline into that and display that in our map.
All right, so I will just quickly go over our main methodology for how we went about implementing this. First, we wanted to define clear roles for everybody so that we weren't overlapping on any work. We had 2 main developers and 2 people working with the data. Yeah, and originally we wanted to, obviously with the limited scope, we had to make several adjustments in order to make sure that we could have a minimum viable product by the end.
Yeah, and I kind of forgot to show this, but our app also isn't like hard-coded. Like you can use any other 2 points in New York City as well. Like we just have these 2 as examples. And it should work here too. So you can see between these 2 points, you're able to like go through where you go, and you might want to avoid here because this zone has more felonies. Another future plan I forgot to mention is having more of a heat map instead of specific points so that it's like more generalized and easier to look at. Yeah.
Woohoo, judges! 3 minutes for judges' questions. Who's going first? Can you hand that?
This is for everyone's questions. Yeah.
So one of the things that struck me is you're looking at routing through New York City, and you're using proximity to crime as your metric. How is that affected by public transit? So, for example, if you're in a subway and there's a robbery on the street above you, you know, it's not really as useful as it would be for a bus at the same route.
Yeah, so this is definitely something we thought of, but just to get an MVP out, we decided to like make these design choices. I think if we were able to like implement like real public transit information, we kind of would move more into like the current events search or citizens app plug, where those will like kind of specify if there are crimes that are happening at a higher rates at like stations. So like I'm sure you guys have seen on the news, there's a lot of like bad things happening in subway stations and specific ones that are kind of more dangerous than others. And so we would switch to using that data instead of just generic crime data for that area.
Great. Great presentation, guys. Very clearly stated. I have one question for you. You may have mentioned this, but it may have gone fast and I was trying to take notes. Are there any plans to use some kind of machine learning, AI, or some kind of standard decision engine to choose a route? I see you have 2 routes planned and there is a point that says lots of felonies were created there. Is there going to be something that chooses the farther route that's away from the crime?
Yeah, so this also goes along with the last question, if I could add on to that, with the specifics of each crime. So if we were to implement an AI model that kind of takes in all the information that we're getting and evaluates it, then it would be able to weight, like the robberies would be worth way less than, say, like a murder or something like that, and that would be a use of AI for this to pick routes.
Great, thank you.
I think like, just going off what he said, like creating some type of scoring system and then having the model evaluate off that scoring system would be something we'd be interested in. And then also, like a bunch of LLMs now have like access to web search, and so they could also like scrape current events and use that as well.
Why you chose this problem?
Sorry, what?
Why you chose this problem?
We're all kind of like from the New York City area, and I'm actually moving like to the city. So like, this is something that I was like looking into, and I was like, you know, where should I live? Like, how do I commute to work? And like he lives in New York City, and this is also a problem that he brought up. And like I've seen like sentiment online recently that like New York City is getting a lot more dangerous. There's a lot more like crimes against people there. So.
All right, my fellow New York Cityans. Okay, thank you.
Thank you.
Woo! All right, I'm gonna try and give the judges time, very fast. We have Green Walk coming up, and we have Smart Predict on deck. All right, Green Walk coming up and Smart Predict. Sorry for the little rock and roll rush, but it seems to be working. Oh, all right, we have a correction. I'm so sorry. They told me they had to leave at 3:45. It's 4 o'clock. Can you guys hold for 5 minutes? Yes. We're changing Smart Predict. They told me they had to leave by 4. Yeah, we're fine. You go. Forget it. There go. There, wait 5 minutes. Go. I'm so sorry. I've never been so unorganized in my life. I know you don't believe that. It's 7 minutes. So you'll go with 7 minutes, you'll be out by 3:45. You believe I've never been so on? The rules keep changing. But what do we do as entrepreneurs when the rules keep changing? What do we do? Pivot, flexibility, turn around, smile, right? And don't let it stop us, perseverance. So sorry about the confusion. Green Walk, you're on. Look at William.
3, 2, 1. Hello, everyone. We are the Green Walk group, and we decided that we wanted to address the issue of accessibility to green space and walkability in green space areas.
Beatley is the head of the Biophilic Cities Network. I don't know if anybody's heard of him or the network, but this is from a paper in 2013, just to give some context for why we're doing this. I won't read the whole thing, but I bolded sort of some snippets. Growing body of evidence of the positive physical and mental health benefits associated with greenery and green elements in living and working environments. Studies are showing the positive power of greenery in the school environment, raising students' test scores, reducing stress, lowered mortality, increased mood, cognitive performance, and even creativity. So these are all very, very great benefits that sort of back this concept. So here's the context. We chose to do our prototype based on where we are. Apologies for the kind of stretched image, but maybe nobody else noticed that. Sorry for bringing your attention to that. But here we are. So we chose to focus on this area around the campus here in Troy. And so as far as users, students, professors, or locals who aren't affiliated with the university, they want to go on a walk, go to class, get a snack, see a friend, and they want to take the walk that maximizes their exposure to greenery. And so they could go to the forest, except the forests are not in town. So how do you get that in town?
So to address this issue of finding the most local green areas within walking distance or along a walking path, we decided to develop an app that maps the NDVI values within our area of interest and overlays it with proximities to walking paths using OpenStreetMap data to make a very accessible way for people to view in real time how their walking path overlaps with green areas.
So this is the web app concept, and on the top left, you'll see just like a welcoming and a positive entry point to the web app, where you can like have like a manual finding of like green spaces, and then on the top right, conceptually, you'd have like a QR code of some sort that would be posted around, and you'd be able to open up that QR code and it would give you the space that you're in, and then you would also have like reviews of that space. So that's just like for the web app overview.
this is the initial kind of approach to using OpenStreetMap and using their tags. As you can see, it's, the surface tag has the grass field, and it's highlighted over the 86 field. We used that originally to try to confirm and validate the NVDI green space as well. This is just a screenshot that our other member, Shannon, who had to leave, was able to get running with GitHub Copilot. Just kind of specify by exporting the XML map from OpenStreetMap, we got the tags to just specify that green space, and kind of had a little difficulty at this stage to try to find out what the units were and how to project it onto real life map distance. Kind of had some improvement in the next slide. We just put a black box over a square around RPI campus area, and this is just kind of what we were able to get. This second part was we didn't get to fully implement, but we were trying to make Google Earth Engine features so that we could create and highlight those walking paths on campus so they could work with our application further down the line.
We use data from the Copernicus Sentinel-2 satellite in Google Earth Engine to get NDVI data. You can see our left image is showing median NDVI around campus, and then specifically the right image is green spaces with an NDVI of greater than 5. And we use Gemini to create some of the filters required to get this high granularity data, including filtering out cloudiness, which you can see on line 16.
Great. You guys are at time. We're going to take 1 minute off the judges. But judges, questions? Judges, any questions? Yes.
So one of the, you're talking about finding green space. And you did mention that, you know, we could always route you up to Saratoga, right, where you've got lots of green space available. So how are you picking between paths that take you way out of your way? How is that indicated, or how are you taking that into consideration during your evaluations?
So our area of interest is mostly within campus. And so you can extend as far as you'd want to and still have the same result, but we mostly wanted to focus in areas that people are trafficking by foot, which would probably mostly be here. We aren't focusing on areas where people would have to drive to or something like that, or take a very long trip. You can buffer to get to those zones if you would like to take a long walk, but depending on how much of a distance you want to travel, you can opt for a closer route within a walkable distance in town, or go further if you'd like to. It's really up to the user. Yeah.
Last question? None? One more quick.
What are the disadvantages and advantages of this, and what are the future plans you have for this?
The advantages is that people can very quickly within their normal day-to-day access green space. The disadvantages, I guess, would be more so within the limitations of the area that you live, like a suburban area or an urban area probably wouldn't have green space that makes you feel like, you know, held or like surrounded in a way that might be more psychologically beneficial. And it would be really nice for future uses of the app if people could contribute reviews and images and comments on the places that they've gone that maybe aren't encapsulated in simply like the NDVI data. They may just be places that they went to that made them feel peaceful and calm.
All right. Thank you. All right, come on, you guys. The team has to leave. Move it. Come on. Thank you, Green Walk. And we are now on Smart Predict. Come on, and you have your 7 minutes. You're going to make it to class.
Okay.
Did you update that?
Oh, why is it? Oh, yeah, I can open the slides.
Judges?
It's right there. Right there.
I need to update the thing. I don't know how. John,
it's just, we're doing it like this.
Oh, no, it's not. That's what I'm trying to tell you.
Yep. Okay.
It's not.
Do you have like an HDMI or like? There it is. Ooh, microphone. Hello. How do I do this? How do I do it? What is this? I'm gonna plug it in.
Help him first.
Plug that in. I'll switch this.
do. Okay, here we go.
Okay, go. Ready?
Ready?
Wait, it's not up?
Not up.
It's not up.
Okay. It's up. Go.
It's up.
No.
It's not up.
Look at William.
That's up. I think that's up.
Hello everyone. We are Team Smart Predict, and we are AI-driven insights for personalized treatment. So we are a team of 3 people. Myself, Shreenidhi Srinivasan, and I'm the designer. And this is Soumeek Mishra. He's the project manager, and he is Robbie, and he is the lead developer. So yeah, off to you.
Okay, wonderful. Hello, hi everyone. Hope you're having a good day. I'm having a good day. Okay, so Smart Predict, what is it doing? Basically, it's taking data.
Move your hands down. We can't hear you.
I apologize. Thank you for pointing that out. I appreciate you. Okay, basically, it's taking data from clinical trials for certain conditions, and it's using those to give summaries of the features of said condition, basically. Do you want to do?
Sure. So let's talk about the problem. So right now the problem is like doctors, when they study clinical trials, they actually have a hard time figuring out what features are necessary that they need to study before and after the treatment. Our objective was try to get an LLM predict those specific features that would at least help the doctor know that those features are the ones they should be looking for. So, wanna follow me, Rob?
Yep. Okay. So this should lead to better outcomes, reduce costs, make resources more efficient, and empower providers. So how does this thing work? Well, we bring the data in, the AI analyzes it, and it gives a recommendation based on that. You know what? And this is about, there's some future features we could add for stuff about the patient in specific, you know, demographics, all that kind of stuff. So it's built in Python. I built the app in Python. I use Streamlit to make like the app. So, you know, I made a little app. And for the AI model, I used OpenAI because that's what I had access to. Yeah, and GPT-4 to be specific. Thank you very much. Now let's demo the application. So here we are. It's built, all that stuff. Look at that. And so we need to put the data in.
Okay, this data set is publicly available from clinicaltrials.gov, and
so
anyone can access it.
I put the data in, and now I'm going to click the Analyze button. It's going to do the analyzing. Look at that, fancy, right?
So the API calls are being made internally.
Yes.
And you just
And
see
then,
the results of what LLM predicted.
And here's the results of it. Yeah. So here's what the summary is, all the stuff, all the relevant features.
These are all predicted by the LLM. GPT-4.
Yes, indeed. Yes. Thank you for that. Yeah, that's our product.
All right, questions. You have 3 minutes to get to class, so let's go. 2 minutes of questions.
I have a very simple question for you. What is gamma?
What is what?
What is gamma?
What is gamma?
The presentation that you made had a watermark on the bottom.
That was, okay.
It's an AI tool for making presentations. Yeah,
Yes.
that's it. There's nothing relevant to the
They're the one who made the presentation. So yes, that's what gamma is.
Figured I just wanted to ask.
Sorry. What?
I said I figured I just wanted to ask.
Yeah, we just wanted to keep everything AI, so.
Very cool, guys.
Next question behind you.
What is the subscriber base for this? Who would be using this?
Who will be using this? Doctors, clinicians, people like that in the medical field who wants to learn about specific features of conditions, you know, symptoms, all that stuff.
The output was not visible because of the color. Is it possible
do you want
to
to see
see
the
the
output?
Yeah, this color. I
Here's
don't
the
think anyone
output.
can read here.
Well, what's your question about the output?
Yeah, in text editor.
Yeah, sure, I can do
just
that.
to make it visible.
Give me a second.
Should have highlighted it, you can see it better. While they're doing that, Transit Pulse, you should be on deck.
Do 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 do. Boop, look at that. There's the response and text file.
It's not visible there.
Can you look behind you? They can't see it. Maybe change the
Oh,
font.
that's completely unreadable. Wow.
But on your screen, it's not.
It is very,
I will verify. Yeah, that's a function of the larger screen. It's very readable and in white on black right there. So it's
I
readable.
apologize that it's not readable. I apologize for that.
That happened to you.
That technical issues. It happens to everyone.
Okay, anything else? Questions?
Are there any existing applications in the market, and how different is this from that?
I don't believe there are any existing applications like this.
So you're saying there's no application at all where you input the data and it will not give you any symptoms or whatever you're...
There might be. There might be.
As far as we know.
But as far as we know, this is unique.
In 2.5 hours. Go figure. I've been meaning to say that.
So
One last
can you,
question.
can you just few lines summarize what you did? You took the data and just summarized with AI, is that?
What's your question?
That's my question.
Can you restate it?
Can you, in few lines, can you describe what exactly you did? You took the data and then send it to AI to summarize it?
Yeah, sure. We use
Oh, yeah, sure. You can try.
we use the publicly available data sets from clinicaltrial.gov. So you can actually filter out the IDs based on a specific disease, let's say cancer. So you could put that in and filter out all the IDs regarding cancers, and you can use that, and you can download the data sets. So we did that, and we uploaded the data set as a CSV file, and then in that data set, it has a specific column called brief summary that gives the summary of the disease for each IDs. So we just feed the brief summary part for every IDs to the large language model. So it will assess based on the brief summary and generate a list of features. Those are called baseline features that the doctors can study for that specific IDs. And those features are the doctors need to keep track on before and after the treatment. So we are just trying to reduce the work of the doctor here, I guess, or clinicians, whatever we call them.
All
We're
right.
not healthcare experts by any means.
You two can connect after. I just want to say 2 of our participants have to run to class. So they're not going to be here. Rob will represent the group, but thank you for staying and pitching, and we're glad you came. Woo! All right, take your laptop.